Welcome back to the Nexus Podcast. Joe Saunders, founder and CEO of Runsafe Security, is my guest. And we're going to talk about the increased targeting of critical infrastructure by advanced attackers. This is a story, a trend that has gained a lot of momentum and attention this year on the heels of disclosures about different groups like Volt Typhoon and Sandworm, with a lot of activity against critical infrastructure around the world. And I definitely wanted to get Joe's perspective on what's happening and what security leaders and manufacturers that support the critical infrastructure sectors, what they should be doing about this and about embedded device security overall. Before we get started, just a friendly reminder to subscribe to the podcast. I've got some great guests lined up, and subscribing is definitely the best way to keep up with the show. We're on all the platforms from Spotify to Apple to Google and well beyond. So please subscribe. Really appreciate the support. Helps out the show. So let's get going with today's episode and bring in Joe. How are you? It's good to meet you.
It's great to be here, Michael, and certainly enjoy the podcast and look forward to the discussion.
Maybe you could tell the listeners a little bit about yourself and a little bit about Runsafe Security.
Sure. Well, I'm founder and CEO of Runsafe Security, and we protect critical infrastructure from cyber attack. And we do that in a relatively novel way. We do that by inserting security protections into the technology at build time, so that attackers cannot compromise software at runtime when it's deployed out in the field. And with that, we serve multiple industries, everything from aerospace and defense to energy and industrial automation, transportation, medical devices, and other high-tech platforms like computer hardware servers, telecommunications equipment, and routers, and others. So when you think about critical infrastructure and all the technology there, Runsafe is deployed to ensure that software is resilient and cyber attacks don't happen.
Mm-hmm. And I know you guys do a lot of work on embedded systems and securing those. And those are obviously prevalent in OT and healthcare and IoT, as you mentioned. Maybe it's a good place to start kind of the discussion, just maybe talking about some of the cybersecurity challenges around those devices. I know that, sometimes there are resource limits on processing power, et cetera. How does all of that figure into the cybersecurity story for embedded devices?
Well, you're exactly right. There's resource constraints. Often there's, whether that's memory or power or the like. And also a lot of these systems, when they were first built or these technologies were first deployed, the consideration for, the devices that operate infrastructure or operational technology networks that help infrastructure operate, no one was really thinking about the cyber attacks on those if you go back 20 years or what have you. Mm-hmm. And it's only been in the last 10 or 5 years where we realize, those assets are fundamental to the operation of things that we rely on every day, whether that's water utilities or the energy grid, or even, software on transportation systems, rail cars, or, airplanes and whatnot. And so what you have are purpose-built technologies that don't have, full-scale operating systems. They don't have, massive networks. They don't have firewalls. They don't have all these things. And what, with the newfound attacks in these areas, those devices, are at risk. And as you say, if they are low power, if they don't have much processor capacity, then security becomes a problem, because if you add more stuff on a constrained device, it no longer functions quite as well. It might slow down, it might overload, it simply might, change its behavior. So you have to be very cautious, and you have to come up with solutions that don't disrupt the economics of those devices, mm-hmm. let alone the performance and everything else that goes with them. So with that, there are a bunch of unusual problems from a security perspective to think about. You can't just assume someone can increase the processor size or capacity. You can't assume there will be more power. You need to ensure that they operate normally, and yet you need to make them secure.
And so is security kind of bolted on somewhere else on the network? And I guess maybe what I'm asking is this a visibility issue in terms of getting an accurate asset inventory and then understanding, where to apply security. Um, Talk to me about that from that perspective.
Right. And there's two sides to the equation as well. So, certainly for an operator or an asset owner that has a bunch of technology they operate within the confines of their infrastructure. So, you think of an oil rig or you think of a cooling system inside a data center. Those things need to operate, right? And there are tons of devices that help the mechanics of that come together. And so there is one challenge of, if you're a chief information security officer or the person responsible for that operational technology network, you do need to know what are all those devices that make the infrastructure operate. And finding those, knowing what software's on them, knowing what vulnerabilities are on those can be a challenge. And so, much like we've done in IT security, we've looked at ways to monitor those systems as a network and look at those, kind of signals, if you will, within the network that might suggest intrusion or detection. But what we've learned over time is that bad actors find a way in. We think about all these devices have complex software supply chain, and so vulnerabilities can be introduced in the open source component that gets put on a device that gets installed inside infrastructure. And so more and more, when we look at what the U.S. government has thought about the nature of what's putting critical infrastructure at risk, we're realizing that the security of the devices themselves is extremely important. And by and large, that burden of making devices secure falls on the product manufacturer
Hmm.
and what they can do to not only make those devices secure, but potentially even make those devices differentiated. And so, I do think that there is, a two part to the equation. There are the folks that operate the infrastructure who have a lot at risk if something's compromised and service is disrupted. But there's also the product manufacturers who are competing with other suppliers who do need to ensure that their customers' service is not disrupted. And they do need to think about the complex software supply chain. I think it's true that there are more developers outside of an organization contributing code when you think about the adoption of third-party vendors and open source software, that a device manufacturer who's producing something needs to think about a lot of different challenges in the software build process in order to ensure that that software is secure. And fortunately, folks like the NSA and the Office of National Cyber Director and CISA have thought about these problems as well, because the overall equation is, as part of the premise for this episode, is that nation states and adversaries and advanced persistent threats are targeting these devices, are targeting the software supply chain, and are targeting the infrastructure itself to potentially disrupt it. And so there's a lot of consideration that the government has put on these topics as well that I'm sure we'll talk about.
Yeah, I mean, well, let's get into it because you mentioned CISA and some of these other agencies, and I know that they're really marketing and promoting um, a secure by design approach and secure by default and by demand. And some of these things mean a little bit different things, but they want stuff on by default, like two-factor authentication and encryption in some cases where it's supported. Um, I would imagine some of that stuff's a challenge with OT and embedded systems, right?
Yeah, those are challenges, and where all of this originated. When you bring up secure by design and CISA's role in November of 2022, the National Security Agency issued guidance on really what put a lot of critical infrastructure at risk, and that is memory safety issues in code that's deployed in
Hmm.
critical infrastructure. And memory safety is considered the most common vulnerability, or memory-based vulnerabilities are the most common ones when it comes to critical infrastructure. They also happen to be the most devastating when cyber attacks do occur. And unfortunately, they also have the most known exploits out there. When you look at MITRE, publishing the 25 greatest software weaknesses today, 3 of the top 8 and 8 of the top 25 greatest dangers happen to be memory-based vulnerabilities. So why did the NSA then issue guidance, and what were the ripple effects across government agencies? Well, the NSA issued guidance because they know that China is targeting vulnerabilities in critical infrastructure, and those vulnerabilities, which comprise often on a device, about 70% of the vulnerabilities are memory-based vulnerabilities, that those kinds of adversaries are targeting those kinds of vulnerabilities. And so the NSA issued guidance saying we need to resolve and achieve memory safety across critical infrastructure and across these embedded devices. And as a result of that, the Office of National Cyber Director came out in March of 23 and said, yes, we make this one of the core pillars of the national cybersecurity strategy for the United States and the president. And what followed from that then was the announcement of Secure by Design. And of course, one of the main pillars of Secure by Design, and if not the main concern or pillar, is memory safety. And so that's where it all originated from. And as you say, folks like CISA are advocating Secure by Design for these reasons. And the practices of achieving memory safety in software is a difficult one. And the reason for that is there are billions of lines of code, millions and millions, if not tens of millions or hundreds of millions of devices, maybe even billions of devices that are deployed that have these vulnerabilities in them. And something needs to happen. Otherwise, critical infrastructure remains exposed to compromise from the most devastating and common vulnerabilities being exploited.
I think that's a really great point, because it's kind of remarkable that buffer overflows are still a thing, and SQL injection and all these common kind of application and software vulnerabilities that just continue to pop up for the better part of 2 decades now. But like you said, you've got people behind software development. You've got millions and billions of devices that are deployed. There's just no way to catch all of this stuff.
Yeah, there's no way to catch it all, but there are ways, to look at your software supply chain and understand and be more transparent and expose the visibility of the vulnerabilities that exist in software. So there are things like software composition analysis. There are things like generating software bill of materials and associating the vulnerabilities with those components. There are things like understanding the risk in the software supply chain. How often are updates? What's the mean time to resolve a bug? There's a lot of really good data and indicators if you have a robust software supply chain security program. And in addition to that, there are methods to eliminate an entire class of vulnerabilities themselves, because, as you say, intrusion detection and response, the problem with that, and no offense to those solutions, they're much needed and they're very important, but they can't necessarily anticipate all the behavioral differences when a memory-based vulnerability, which might be fileless, is an attack that people can't detect.
Right.
And there may be no prior signal to it. And so eliminating an entire class of vulnerabilities through memory protection is a means, and there's a couple layers of that. And certainly what the government had initially advocated for was to ask organizations to rewrite all their software in memory-safe languages. But obviously, and the government agrees that is no longer practical because of the billions of devices. And as you know, in this space, the 10 to 30-year lifespans of these products, the economic equation's not working in our favor to just rewrite everything. And also, then to your point, a lot of these different components, there may be interface issues, compatibility issues, and writing things in new languages, they just might not work. And so, there are fortunately other means to protect against those and apply software memory protection without rewriting software. And so it is a holistic approach. It's a defense in depth approach. Certainly, if you adhere to the principles of Secure by Design from CISA, you will be publishing, or product manufacturers will publish their roadmap to memory safety. And that's a key point. And I think we all need it. And we all need to think about it and take it seriously because the threat is so high coming from China and other places, as you said in the opening, things like Volt Typhoon, Salt Typhoon, and these other exploits coming or advanced persistent threats coming from China are in fact targeting memory vulnerabilities and exploitation of them. So the need is urgent, and the solutions are complex, and the software supply chain is complex. So, it is a gnarly problem, but it can be solved relatively easily without rewriting software.
Speaking of these groups, I mean, what we've seen some disturbing activity, to say the least, from especially Volt Typhoon, and I'm just, would love to start that conversation with you about, some of those threats and, what really has caught your attention in the past 12 months, in terms of, like, it particularly seems that strategically they've changed course and they're moving toward destructive attacks. And I think you hinted at it earlier, specifically targeting OT, IoT specific attacks. So just kind of what's your perspective on what these groups are doing now strategically, especially?
Well, if I look at it at a macro level and a strategic level, it's very obvious what's happening, and you've suggested it. But if you look at the history of China's, kind of attacks on U.S. Prior to what I would say would be maybe 2015, prior to 2013, if you look at the 90s, 2000s, and even through 2015, there was a very concerted effort and persistent approach for stealing intellectual property and for maybe copying technology and then producing something cheaper, which is a form of economic espionage and economic attacks. Because if you can copy technology and produce it and ship it in a cheaper way, then you are disrupting the competitiveness of, say, the incumbent, who may have been put in place because of innovation, because of patents, because of other things that help them solidify a position to really create tremendous value, not only for their shareholders, but for their customers, delivering on the value proposition. Now, again, if you think about how persistent that was, 90s, 2000s, 2015, that was kind of the rule. You thought about IP theft. But now you're thinking about pre-positioned payloads to disrupt intellectual or disrupt critical infrastructure, disrupt operations. And if you apply, if you think about all the resources China put into the first wave of IP theft, well, they're doing the same on the cyber front from an attack perspective. And so that's what has struck me is we've seen it now in multiple industries. And if you look at the telecommunications networks that were compromised at a really deep inner level, it's very scary to think that China can, disrupt operations of the telecom infrastructure at that level. If you think about that, looking at automotive cybersecurity and the effects on, compromising LiDAR and sensors and things on cars, you can imagine the effects that can have. If you think about that, in water utilities, and you think about that in energy grid, and you think about a very motivated, persistent adversary who's looking to, potentially use a payload to their advantage at some point in the future, then you can, get really nervous about what that threat could end up being like. And I don't mean to be, doomsday, like the whole world's going to shut down one day. But just as I didn't think there would be one major IP theft, there were thousands of IP thefts, right? And, disruptions here and there, and collecting data here and there, and understanding voice calls here and there, they all add up into a pretty massive operation. And that's what strikes me about China's cyber operations. And not to mention, other things that we don't necessarily have to get into around information warfare and the like. But what happens is attacks, if you think about Taiwan, attacks on its critical infrastructure could undermine confidence in the government to provide basic services. Attacks on U.S. critical infrastructure could undermine U.S. government's involvement in foreign affairs, maybe defending Taiwan. Why should we defend Taiwan if we can't protect our own critical infrastructure? So there's these motivations and this persistent attack method that worries me. And the pre-positioning of payloads targeting memory-based vulnerabilities across critical infrastructure is a really, really good example of that. Now,
Right.
Some people might not like what I'm about to say, but I will say this. If we compromise, if we go back to the OPM breach and the data that was stolen, if we think about monitoring social media accounts, things like TikTok and other things, and data leaving the US and going to China, and marrying those two data sets, you've got cleared personnel and their children, and now you have those children grown up watching, TikTok videos and other videos and other messages. And then you've got location data in cars and phones. And then you've got, all sorts of other information. Well, again, I'm not worried about any one event, but the totality of that tells a very different story. And the US needs to be prepared for countering all those threats. And so if the water utility goes down, which we know there's 10,000 water utilities across the country, I don't think they have all the resources to have really solid cyber
Right.
defense. And so what it means is we need to rely on the software makers, which again, going back to CISA and the NSA, we need to secure these software components so that critical infrastructure is secure.
Mm-hmm. How do we impart that urgency upon the software makers or the OT and IoT operators, asset owners? How do we impart that urgency upon them now? Or do they understand the urgency, and is it a resource question?
I don't think they necessarily understand the urgency, but I also think there is resource issues, of course. And so both are, challenges. Both are challenges. And, what I would say is generating software bill of materials and identifying vulnerabilities associated with those components and sharing that information helps in some ways because it's transparency, it's visibility, creates discussions. It can even improve disclosures and customer support issues if in that regard. So that's one way to quantify the type of problem that exists in using tools. The other way is also the data inside these OT networks, and with the help of solution providers that work directly with the operators and the asset owners to do that discovery, to find those assets, and to develop a risk management framework that identifies what the most crucial things are to update. And along those lines, we talked about secure by design, but I do think the asset owners do have a role to help elevate the story, which is also what CISA is promoting, is secure by demand. And so if you're a CISO at, I don't know, Duke Energy or Duke Power, or at DTE, and you want to ask your suppliers, how are they doing on the memory safety question? How are they doing on security of their devices? What's putting my infrastructure at risk? Those are good questions. And so I would encourage anybody to look at the resources and the literature that CISA is producing in these areas to think about, what can they ask of their suppliers to ensure that their infrastructure remains resilient.
So much critical infrastructure is privately owned in the U.S., and it's kind of a unique situation. I'm just curious what's your perspective on, what kind of complexity does that introduce in terms of, just comprehensively adding security to these critical sectors?
Well, I think that's why CISA is issuing guidelines and secure by design and secure by demand and promoting the need for it and asking people to software producers to sign up for a commitment to secure by design. And again, there's 10,000 water utilities. We know that water utilities are, subject of targets from other nation states. And so, if you think about FEMA or you think about Homeland Security, they don't control the utilities and they don't control the water systems, but we do depend on them. And in some areas where we depend on them, there are water utilities that support cooling systems in operational technology environments that the Department of Defense relies on.
Mm-hmm.
And so there are, leaders in the space who know that there are alignment issues. We also know that the U.S. government does own its own critical infrastructure. And so the U.S. government taking steps as a leader to help drive vendors to adopt certain practices if they want to deliver into critical infrastructure the U.S. government owns is also a way to drive it a bit, to create requirements for security. And if we do that, and if there's promotions through and education through secure by design, secure by demand, if there's pull of government for its own critical infrastructure, if there's cross alignment with DoD and water utilities and energy grid, and think of all the bases around the country, there are stakeholders in the equation. And so I think there's a lot of ways to get there. But to your point, these are commercial organizations that have to decide also what's best for their own shareholders.
Mm-hmm.
And so there needs to be innovative solutions that are easy to deploy, that don't cost an arm and a leg, that don't force people to rewrite software, that don't, don't prevent you from, advancing other innovations in their products. And so we need to think about the ROI, the cost, and the problem, and prioritize, where things can be done. But I think there's a lot of tools there, as I just described, to help us get there.
Mm-hmm. I mean, there's such kind of geopolitical capital coming out of offensive security, and it doesn't even necessarily have to be a damaging type of attack. They can just, like you mentioned, hit a small water utility and get some attention, sow some chaos, sow some distrust in these systems, and that's as much of a win as actually damaging any infrastructure, I would imagine.
Yeah, and my co-founder and I, Doug Britton and I, we founded Runsafe on an economic principle, not a technical principle. And the economic principle was, if an adversary spends a lot of time getting their offensive tools on a target in order to administer an attack, then that might take months and months. You have to reverse engineer devices. You need to breach something and get on target. You need to infiltrate the supply chain. You need to test your own code and make sure it works without disruption. You need to make sure that code doesn't get detected once it's deployed and looks legitimate. And so it's a serious software operation to get nefarious software on a legitimate device without detection.
Mm-hmm.
And then it has to work. At the moment that payload is supposed to be delivered, it has to work. Otherwise, the mission of that operation is a failure from that sense. So our economic principle was to shift the economics back in the favor of the defender. And so imagine you're the adversary and you spend all this time, and when you go to deliver the payload at some point in the future, poof, nothing works. You've just wasted a lot of time, a lot of years, a lot of money, and you have to go back to the drawing board. And so I think that can be a deterrent. And I think the U.S. government does recognize that is an economic principle that can be used in an asymmetric way to thwart what looks to be a very, very well-resourced adversary in China, who has, according to Christopher Wray, director of the FBI, a 50-to-1 manpower advantage in cyber warfare. So they have 50-to-1 advantage over the U.S. in cyber warriors, if you will.
Right.
And so we need asymmetric solutions, asymmetric cyber defenses. We need folks who can defend OT networks and OT systems and monitor those systems and those networks. And we need people to defend the software. And we need organizations to realize they can do that easily and maybe save some money doing it. And all the while shifting their economics towards even further innovative solutions.
Yeah. I'm glad you brought up the word deterrence, because there definitely does seem to be a lack of kind of defined red lines in cyberspace, and it does seem that some adversaries, anyway, uh, don't seem to have a problem crossing them. So I would imagine deterrence has to be a discussion that's being had at some high levels as well.
Right. And, deterrence, obviously a key thing, and disruption of, cyber tools shift or put on device downrange by an adversary. They need to be disrupted or, prevented from working. And so with that, there are, some challenges to that. I mean, we don't really have in the public perfect information about attribution. And so in some ways, deterrence is also, takes different forms, and it can get to, I've seen a lot of cooperation between CISA, the FBI, Department of Justice, attorneys, Interpol, and other organizations that are going after cyber attackers. But it's very, very hard because you have to get the attribution right first. And so
Right.
all the while those efforts are going on, we need cyber defense tools that prevent the damage, even if those things can't be fully completed. But thank goodness those organizations I just mentioned are able to communicate at the levels that they could. And I think about the cooperation in the interagency and how important that is in the overall equation of deterrence, because legal action, prosecution, imprisonment, arrests, those are deterrents as well, but they're very hard to do. And I think the U.S. and its allies attempt to cooperate, but nonetheless, it's very, very difficult.
Yeah. Joe, I just want to wrap up with one question, and before we do, I want to thank you for your time. This has been a really important discussion, and it's been great stuff. And I just, give you a chance to kind of maybe impart some advice, whether it's to manufacturers or security leaders within critical infrastructure sectors. I think it's time to be proactive about securing these critical networks, and just do you have one or two or three things they should be doing in that regard right now?
Well, I do like the principles of secure by design and secure by demand. So if I had two bits of advice or special requests from my little vantage point, and that is that operators and asset owners talk to product manufacturers and suppliers about security. That's number one. Simple discussion, but do it with full conviction that it's good business for you, good business for them, and come up with ways to do it. The other approach is to specifically talk about memory safety. There's a reason the NSA put it out there. And yes, it's a national security issue, but it is also a continuity of operations issue for operators. And product manufacturers have operators' interests in mind because they are their customers. And so I think talk about security and specifically talk about memory safety. And I think if everyone does that, the ball will move forward, and critical infrastructure will be more resilient, and our national security interests will also be assisted.
All right, Joe, that's a good place to leave it. Thanks again for coming on the podcast and for giving me your time. I think people are really going to enjoy this discussion, and it matters, these kinds of discussions in this kind of context to what's going on out there. So I really appreciate you coming on.
Well, I appreciate the chance to talk about it, Michael, and I appreciate all that you do, and really enjoyed the discussion. Thank you.
Thanks. Have a great day.